I think there will always be people who will be taking care of their private keys and they will not be losing their Bitcoin. But anyways, I think what you are alluding to is that as long as you keep dividing the currency, then the divisions of it become more and more valuable in a way. But also another answer is that maybe not all cryptocurrencies, all is to cryptocurrencies is Bitcoin. Maybe there's a lot different properties that people need, different utilities that people need to implement on top of cryptocurrencies. So I think the technology is here to stay. It's as we will see next class. It's the first time in history that we are able to not having the need to trust some organization in order for us to make specific actions, such as transacting with our funds or storing our funds. And it's also the first time in the history where you can have self-sovereign identity in a way. So because we will talk about private keys and public keys, if essentially the only person that can take Bitcoin out of your Bitcoin wallet is whoever has the private key, which is something like a password. And you can prove that you are who you are just by having the password. So in the past, in any other historic event since the beginning of time, there is either I'm living in a village 1,000 years ago, that and then everybody else in the village know who I am, and that's how I can establish that this I can give you this piece of land, and then everybody is a witness, so your piece of land is yours. Or in the recent years, we have to use passports or credit cards or intermediaries. So the intermediary would be in the passport example would be a country that issues the passport. So then everybody trusts that the country gives one passport to one person and the passport is legitimate, or the bank institution, which basically gave you the credit card or the debit or the bank account number, and then people have to trust. But with this technology, it's the first time that that you can have this self-sovereign identity, and I think there is a lot more innovation that will happen because of this property. We have a lot more things to invent because of that simple thing.
Thanks.
There is a rule that is the longest chain rule. So whichever one, there could be forks of Bitcoin, and but there's always one fork that is longer or has much higher difficulty than any other one, and that is the official Bitcoin ledger that people are following. That's one. Well, that's one answer to your question. And the other answer is that it is very possible that different peers include different set of transactions in their blocks. That's perfectly fine. But in the end of the day, one peer is going to find the nonce. It's going to essentially mine this block. Then whatever transactions this peer selected, these are the transactions that will be recorded by everyone else. Because this person is going to say, here's my nonce. The nonce is going to come here. And it's going to say, here's my Coinbase. Coinbase is going to come here. And then he's going to say, here's the list of transactions that I had. So the decision is made, and we're all moving forward to the next block. Whomever's block reaches more people, more other nodes earlier than another, more other nodes will basically adopt it, and they will start moving into the next block. And when they receive, if Alice arrived first, and then these nodes are already mining the next block. If they receive Bob's or Charlie's block, they will say, no, I'm actually already minting the next block. I'm mining the next block. I don't care. Basically, they will recognize this as a fork, and they will keep doing what they are doing. If, on another hand, though, let's say this is also possible if there was a network split. If the entire internet of a specific country was down for an hour, then all the miners of that country would be basically mining by themselves and making decisions and creating blocks. And all the miners of the rest of the world would be creating blocks as well. So in this case, during that 1 hour, because the miners of that country are not that many, they are fewer than the rest of the world, let's say, excluding a certain country, then they will have produced not by 1 block every 10 minutes, maybe they have produced by 1 block every half an hour. So they will have 2 blocks produced in that 1 hour. And the rest of the world will be producing, maybe because they lost the country, they will not be producing 1 block every 10 minutes, they're 1 every 11 minutes. So they will have produced about 5.5 blocks. So in the global version, the blockchain has 5 more blocks. In the other version, it has 2 more blocks. So that blockchain is smaller. So everybody is just following the longest chain, the one that has the more work, which we will see in the next class exactly what this means. So yes, forks can happen, and there is a way to resolve them. That's why there's a property of safety and liveness. So Bitcoin, and there is a theoretical theoretical proof in fault tolerant distributed systems that you can't have really both. And Bitcoin is guaranteeing liveness, which means that no matter what, even if there's an atomic bomb, 90% of the world is gone, the remaining 10% is going to keep producing blocks. But so liveness, it's going to be live, it's not going to block, but it has the problem that it might not be safe. So in that situation we had where the country was disjoined by the rest of the world, they will have a different version, and that version will vanish after the whole network reconnects. So Bitcoin doesn't guarantee safety, but it guarantees liveness. Other cryptocurrencies guarantee liveness, but not safety. For example, banks always guarantee safety versus liveness. So if there is a chance that your wire transfer might be lost, then the bank stops, says, sorry, we're down today. The server is not working. Just come back later. We can't send wires. That's the guaranteeing safety versus liveness, but Bitcoin doesn't guarantee that. And I think we are ending in about 5 minutes, so we have time for a few more questions. Keep shooting. As a miner, what you do is you basically come and put your name here. You're a miner Alice, and you put your name here, and you press the mine button. And you keep pressing the mine button for the rest of your life. And I guarantee you that you will never get a block, because it's so unlikely that then the transaction happened. So when it happened, then they go back to the mobile app that has or the website that. Yeah, Bitcoin has a very specific scripting language that you can apply. So you can do very simple things such as multi-sig wallets and things like that. But what the breakthrough of, well, let's say, the innovation of Ethereum is that Ethereum's programming language is completely generic. So you can do almost every program that you can imagine. You can't do input-output stuff, but you can do any program that you can imagine. Having said this, the whole Ethereum computer is comparable to an extremely slow computer from the 70s. And the reason it's not like, the reason why this is the case is by choice, because that computation is being replicated across every single node. So you don't want it to be running machine learning algorithms. You want it to basically make sure this smart contract, when you send it funds, it responds this. Like you can create an escrow smart contract, or you can create your unit swap, or what you want to create on it. But you can send it funds, it responds this. Like you can create an escrow smart contract, or you can create your unit swap, or what you want to create on it, but you can create a complex algorithm.
Thank you. That's very helpful.
Okay, complex algorithm.
Thank you. That's very helpful.
Okay, cool. Well, thank you, everyone. We'll be on Slack, and I'll see you again next class.